Hello friends. You must have seen the famous movie of the Tacoma Bridge dancing and crumbling like a paper ribbon in the wind. Many people read in textbooks that the cause of its collapse was resonance, or the synchronization of the wind frequency with the bridge, but the truth is more interesting and frightening than that. Today I want to see exactly why this 4-month-old bridge collapsed. 1. A tempting but deadly design. The Tacoma New Bridge was built in 1940 with the idea of lighter and thinner. To save money, the engineer removed the large stiffening girder and replaced the deck with solid steel girders only 2.4 meters high. The bridge became incredibly flexible. From the very first day, the workers nicknamed it Roaring Gertie because it constantly went up and down. But this was only the beginning of the disaster. 2. The morning of November 7, 1940. That day, the wind blew at a speed of 67 kilometers per hour. Until then, the bridge had only oscillated vertically, but this time a new movement began, twisting. The deck began to sway around its longitudinal axis. That is, one edge of the road was about 8 meters higher than the other. This intense twisting, within a few minutes, crushed the concrete and finally the deck collapsed. 3. The real cause, not resonance, but torsional flutter. Let me tell you exactly what the cause was. If it were resonance, the oscillation would stop when the wind speed changed, but here the more wind blew, the more terrible the movement became. The reason is a phenomenon called torsional flutter. How does it work? Imagine the deck like an airplane wing. The solid steel beams did not allow the wind to pass between them. When the wind blew, the bridge twisted a little and changed its angle. This change in angle caused the wind to exert more force on the bridge. That extra force twists the bridge even more, and this positive feedback loop intensifies moment by moment. The bridge was essentially dancing with the wind, but this dance itself was providing the driving force for the collapse. This is an aerodynamic instability that has nothing to do with the natural frequency of the bridge, but rather with its geometric shape. 4. A big lesson for engineering. It's interesting that only a dog got stuck in the car and no one was killed. But the impact of this disaster on structural science is indescribable. Engineering realized that it was no longer just static resistance that needed to be considered, but wind dynamics, and aerodynamic effect, the most important element of suspension bridge design. The new bridge, built in 1950, used perforated lattice girders instead of solid girders to allow the wind to pass through it and prevent such deadly flutter. So if you ever see the film The Dance of the Tacoma Bridge, know that you are watching a victim of torsional flutter, not a simple resonance, but the very shape of the bridge causing the wind to tear it to pieces.